All right, so that first part caught me by surprise where my video here stopped recording. So let's start again. So an even function is defined as a function where f of x, negative x equals f of x. So, for all x in the domain. On a graph, the graph is symmetric with respect to the y-axis, which means it is a reflection across the y-axis, or we can think as the y-axis is a mirror, right? Notice, by the way, if you put your nose on the mirror, it doesn't matter where you put it, it's going to be reflected right across. Okay, so it doesn't matter where the y-intercept is in this case, as long as every other point is a reflection across the y-axis. An odd function is a function such as that f of negative x equals f of x for all x in the domain. On a graph, the graph is symmetric with respect to the origin. What does that mean? If you rotate the x-axis 180 degrees, it's the same graph. Notice, and it has to have the same y-intercept. Okay, so notice right there, rotate 180 degrees means flip it upside down. So I'm going to flip this upside down, and we'll see if it has exactly the same y-intercept. Yep, the y-intercept is 0, right? Okay. Notice when we flip, by the way, when we have it right side up, that's positive. When we flip it, we have to think of that also as positive. Okay, positive, negative, negative, positive. Okay, same exact graph. Okay, alrighty. So we know how to find it on a graph. The graph is pretty easy, right? How about when they ask us, is the function even, odd, or neither, but they don't give us a graph? Right, and we're not allowed to use graphing calculators, so that leaves us to the following: the definition. Yeah, f of negative x has to be f of x if it's even. F of negative x has to be negative f of x if it's odd. Okay, so this is what it means. It means we have to know what is f of negative x. See, because we have f of x, so to compare it to f of negative x, we need to know first what is f of negative x. And then to compare f of negative x to negative f of x, we also need to know what is negative f of x. Let's find those first for this first example. So, and I'm going to do 6 and 7 exactly the same way. Okay? So first I want to find out what is f of negative x. You know what, let's put negative x in red so we can better highlight it. Okay, so f of negative x equals 5 times whatever we're going to put in place of x to the 6 minus whatever we're going to put in place of x to the 4. And what we're putting in place of x is that, negative x. Okay, and then I'm going to just simplify that. So what is negative x to the 6? Well, negatives, the way they work is every 2 negatives make a positive. So here we're multiplying 6 negatives. This will be a positive 5x to the 6th. And over here, minus the negative x to the 4th will be a positive x to the 4th. Okay, because every 2 negatives again make a positive, and you have 4 negatives, right? Negative x times negative x times negative x times negative x. That's positive, positive. All right, and then what is negative f of x? Okay, so negative f of x is negative whatever f of x is. And f of x is 5x to the 6th minus x to the 4th. 5x to the 6th minus x to the 4th. I'm going to distribute the negative just to make it easier to compare the two. This will be negative 5x to the 6th plus x to the 4th. Okay, so if these two are equal, then the function is odd. Okay, so there's these two, right? F of negative x, negative f of x. They're not the same, right? In fact, one of them has a negative x to the 4th, the other one has a positive x to the 4th. If these two are equal, then it's an even function. So we need to check what's f of negative x, what's f of x. Yep, those two are equal, therefore it's an even function. So we will say because, I'm going to say it's even, that's the answer, right? We don't need to say any more than that. But I'm going to say because f of negative x equals f of x. All right, let's start off number 6, and then number 7 you guys will do all on your own in class. Of course, we will discuss it in class. All right, so first, the same as the first one, we want to find what is f of negative x first. So f of negative x equals 2x to the 3rd plus x. All right, notice what am I going to replace in place of x? Negative x. Okay, so f of negative x, oops, I forgot to the 3rd power here. So this is, so when you have multiplied three negatives, because this is negative x times negative x times negative x, right? The negative x to the third. There's three negatives, so the answer will be negative. So it'll be negative 2x to the third plus negative x is just minus x. Okay. Those are not the same, by the way, right? So notice we can already tell this is not even, right? Because these two are not the same. All right. Let's find negative f of x. So this will be negative of whatever f of x was, 2x to the third plus x. Okay, so when I distribute the negative, this is negative 2x to the third minus x. Notice these two are the same, right? F of negative x is the same as negative f of x. So therefore, this is an odd function. I think I was just going to start it, but let's finish it off. What the heck? So the function is odd. And then y. Notice we don't have to answer why, right? They're not asking us why. Because, well, I'm going to let you finish that. Because, all right. And then number 7, you'll do on your own. We'll do it in class. All right, let's try number 8. Notice number 8 is a little bit different. It's a table. But they ask us the same question. Fill in the table to create an even function. I mean, it's the same problem, right? We need to know what even means. What does even mean? It means that, right? So the first thing I'm going to do is I'm going to write that. F of negative x has to equal f of x. Okay, notice this refers to values of x, right? F of x, negative x is the same as f of x. What values of x do I have? Well, I have negative 2, 0, and 1. Okay, notice I don't have negative 2 and positive 2, right? And I don't have negative 1 and positive 1, but when I write it over here, I'm going to use those values of x, and I'm going to say, so f of negative 2 has to equal f of, well, f of negative x has to equal f of x, f of negative 2 has to equal f of 2, right? Even though I don't see a 2 over here anywhere, okay? And I'm going to say f of negative 1 has to equal f of 1, okay? Why do I write negative 1 and 1? Because I see the 1 there, right? So I wrote f of negative 2 equals f of 2 because that negative 2 is there, and I wrote f of negative 1 equals f of 1 because I see the 1 there. And I'm going to write f of negative 0 equals f of 0 because I see 0 there. F of negative 0 has to equal f of 0. Okay, so is there anything we can replace in this statement? Like, do we know what f of negative 2 is or what f of 2 is? Yep, f of negative 2 is 5. So I can rewrite this as 5 equals f of 2. This one, do I know what either one of these is? Do I know what f of negative 1 or f of 1 is? Yep, I know f of 1, so I'll replace f of 1 with negative 5. So f of negative 1 though will stay, right? F of negative 1 equals negative 5. And then this one, f of negative 0 has to equal f of 0. And do I know what f of 0 is, or f of negative 0? So f of negative 0 has to equal, what was f of 0? Oh, we don't have a value for that. Oh. I'm going to leave it as f of 0 then. We don't have a value for that, right? Okay, now we do have a value for negative 0. Do we know what a negative 0 is? Right? What is negative 0? Well, it's just 0. So we can actually rewrite this as f of 0 has to equal f of 0. Okay? All right. Let's fill in what numbers we know. So looky here. 5 equals f of 2. Oh, we don't have a 2. Well, we'll put one in there. That's our job, right? So f of 2, so we want x equals 2, and f of 2 is 5. Oh, did I write the wrong numbers? F of negative 2 is 3. I'm sorry about that. F of negative 2 is 3. And f of negative 1, okay, so f of 1 was 5. Okay, so f of 1 was negative 5. So, so f of 2 is 3. I'm sorry about that. F of 2 is 3. And then we have f of negative 1 is negative 5. Notice we don't have x equals negative 1, but we have a place to put it. Negative 1 is negative 5. Yeah. And we don't have to put them in that order, by the way. Like, we could put the 2 here and the negative 1 there. It does not matter where we put it. But then f of 0 has to equal to f of 0. How can we make that happen? Well, any number will do, right? Whatever number we put here will be the same number as we put over here. So we can pick any number here. I'm going to pick 2. It does not matter what number we pick. I'm going to pick 2. Or any other number. Notice if f of 0 was pi, f of 0 would also be pi. All right. How do we finish off the last one? Fill in the table to create an odd function. So first I write the definition. F of negative x has to equal negative f of x. Okay. I look at the values of x that I have. And just as I did on the first one, I have the same values of x. So I'm going to say f of negative 2 has to equal negative f of 2. F of negative 1 has to equal negative f of 1. And f of negative 0 has to equal negative f of 0. All right. I'm going to let you guys do the rest, see what you can replace. Oops, not on the first one. And then see what you can come up with, and we'll discuss it in class. All right, this will be the end of 4.1.